Alrighty guys, how are we going? Good, hopefully. Now, it's going to go through a couple of Pythagoras examples for you. Now, I'll show you the way I would like you to work it out. And hopefully, this helps to clear up a couple of discrepancies that you may have faced. So, let's have a look at this question here. There is a triangle. It is a right-angled triangle, which you can see from the right-angled sign there. The hypotenuse, the longest side just here, we know that. It is the square root of 10 centimetres. Then we've got x there, which is unknown, and x on the other side there. Alrighty, two unknown sides and only one known side. Can we tackle this problem? Is there enough information for us? Let's go through and actually work it out and see. So, the first step I would like you to do in all of your Pythagoras problems. Who can tell me what it is? Have a guess. Write the formula out. C squared, oh that pen's not very good. We'll make it work. Maybe this one's better. Actually, I've got a blue one. Found it. C squared equals A squared plus B squared. Now we'll label our triangle. C being A, so let's fill in the gap. Square root of 10 squared equals x squared plus what's B? X squared. Alrighty, now, can we tackle this problem? Yes, we can. Let's keep going through. So, x squared plus x squared, can we do that? Alright, here we go. Square root 10 squared equals x squared plus x squared gives us 2x squared. Alrighty. Now we can keep that as the square root if we like, or we can do the maths with it. So the square root of 10 squared. Now that actually just leaves us with 10 because we've got a square root there and a square sign there. They sort of cancel each other out and we just get 10 equals 2x squared. Now, what can we do here? 10 equals 2x squared. That 2x squared, we can get that x squared by itself. By instead of timesing by 2, we divide this by 2. So what we do to this side, we need to do to the other side. So we end up having 10 over 2 equals x squared. Now we can go through and do the maths there. What's 10 divided by 2? 5 equals x squared. So we want to get the x by itself. So we would square root both the sides. Square root of 5 equals x, and the square root of 5 is 2.24. So, we can circle both of these here because both of these answers are correct. Square root of 5 equals x, that is correct, or 2.24 centimetres equals x. So that is how you will go through showing all of your working out. Now, we only had one known side. Could we still do it? Yes, of course we can. Awesome. That is one example. I'll go through another one in a moment. Alrighty, our second example, and this one right here is an absolute cracker. It's a good one. So, right angled triangle, yes. So we're using Pythagoras. Alrighty, so let's first step write out our formula. C squared equals A squared plus B squared. Alrighty, so what is in place of C squared? We have 1. 1 squared equals, I forgot to label the triangle. A squared equals Square root of 3 over 2 squared. Plus b squared is x squared. Alrighty, now we can go through and do our first few steps in the math. So 1 squared, 1 times 1 equals 1. Now, that looks pretty funky, but we can actually just convert that back to a whole number by doing the maths in itself. So grab out your calculator and you can plug that into your calculator. Making sure you're using brackets when you need it. So the square root of 3 over 2 to the power of 2 gives us 0.75. Alright, cool. So 1 equals 0.75 plus x squared. Apologies for the messy handwriting. Now we want to get this x squared by itself. So we've got positive 0.75 there. We can take that away. If we take it away from this side, we need to do it to the other side as well. So we go over here, 1 minus 0.75 equals x squared. So again, we're going through all these steps. So over here, we will go 0.25 equals x squared. Now, we want to get that x by itself. It's squared here. What do we need to do to both sides? Square root, exactly. So the square root of 0.25 equals x, and you can do that, will that be a half? Actually, 1 over 2 equals x, that is the square root of 0.25. Half times a half is 0.25. Awesome! That, one second, I'm going to circle both of these. So that right there, our two answers, they are both correct. Personally, I prefer it written as, what units are in meters? 0.5 meters, as it is a bit easier to understand. I find that easier to interpret than having it as a square root. Awesome, there's your second example. Alrighty, let's have a look at another example. Okay, so we've got a little funky triangle over here. Yes, half of this is my bad drawing, but the other half is actually how the problem looks. So when we first see it like that, we think, wowzers, what is going on there? But we can break it down and actually get two triangles out of this and do Pythagoras that way. So we want to find out x and y. We want to find out both of these values here. So we identify, we have two unknowns. Now the way we can tackle this is we can break it down into two triangles. So triangle 1 would be this triangle here, and triangle 2 would be this triangle just here. So we do the first triangle first, and then that will give us that x value there. So I'm going to redraw that initial triangle. Nice right angled triangle for us to be playing with. 1, 2, and y is the unknown value. So the first step, like with all Pythagoras problems, I will label the triangle C, A, B. And then I'll write out the formula. C squared equals A squared plus B squared. Now, just like all Pythagoras problems, I utilise substitution. C squared, y squared equals, it's meant to be an x, not a y. Come on, you should have pulled me up on that. X squared plus 1 squared plus 2 squared. We can go through and we do our maths there. X squared stays the same. 1 times 1 is 1, plus 2 times 2 is 4. x squared equals 5. Now we need to do the square root of both of those. So x equals the square root of 5. Therefore, x equals 2.34. 2.24. X equals 2.24. Alrighty. So there is all our working out there for that first triangle. Now we can redraw that second triangle now. And we have y here as an unknown. We have 1. Now, I'm going to write here the square root of 5, just so we have complete accuracy with our answer. Square root of 5. Because I rounded that off to do 2 decimal places. Now we can label our triangle here. So we have C, O, and B. Now, like with all good, can you see that? Hopefully you can. Like with all good Pythagoras problems, our first step is, after we've labelled the triangle, we will write out the formula. C squared equals A squared plus B squared. C squared equals Y. A is square root of 5 plus B is 1. Alrighty. So, y squared equals square root of 5 to the power of 2, that gives us 5. Plus 1 times 1 is 1. Y squared equals 6. So we go through now, we want to get y by itself. So y equals square root of 6. Now, I'm sure you can all tell me that. What times itself equals 6? That would be 3. So we can circle our answers there, and there, as well as over here, there, and there. And that is how we'll tackle a problem involving more than one right-angled triangle. And again, multiple ways to write your answer. As a whole number there, I feel it's a lot easier, makes more sense than having it as square root. Awesome.